Hi, everybody, and welcome to this session, the last one of the day. Everybody having a good I/O so far? Nice. Excited for the concert tonight? Yeah. So thanks for spending some time with us beforehand. I'm Laurence Moroney.
I'm Kaz.
And we're here today to talk about machine learning plus IoT equals a smarter world. Now, that's a little bit of a riff on a famous computer science book. Anybody know what that is? Algorithms plus Data Structures equals Programs by Niklaus Wirth. It's one of the seminal works in comp sci. So we said, hey, we want to do a little bit of a riff on that. And it's also really about what's going on in the world today. That there's two major trends going on. Number one is the rapid rise of IoT, and number two is the rapid rise of AI and machine learning. And in many ways, these are kind of, they're intersecting with each other to create some really cool new scenarios. So we wanted to talk through a few of these scenarios and give some demonstrations. The first one we'll give is, let's take a look at really cheap IoT sensors that will do something in this case, we're going to take a look at those that measure air quality and how they can push data to the cloud and how we can use that for machine learning.
And we'll also look at how the cloud can be an empowering tool for IoT and AI with products that help you collecting data and analyzing it and learning some intelligence with the deep learning models.
And then the third one will be as some of our devices are practically mini computers like Raspberry Pis and our handheld devices, that what can we do about on-device inference with them as well? So we'll take a look at some of the examples of that and some pretty cool stuff that's happening there. But first of all, some numbers. According to IHS research, there are expected to be 31 billion connected IoT devices by the end of this year. That's a lot of devices. And those devices combined, we found the same research is showing a 27.6% compound annual growth rate of the data that they are pushing to the cloud. So 31 billion by the end of this year, and every year the amount of data that they're pushing is growing by 27.6%. And that's a lot of data. Now, what are we going to do with that data? Well, obviously, there's the usual things, filtering, sorting, querying, all that kind of stuff. But we can also use that to start training some models. And all of that data and all of those models, machine learning models, can then be used to generate intelligence and to help us to start making intelligent decisions based on the data that's being generated by our devices. So the first scenario I wanted to look at was thinking about simple sensors that give us smart solutions. I just wanted something with 4 S's on it. Easier to remember that way. And an example of this is there's these little devices, and if you've ever done any kind of hardware hacking, and there's a device, the one on the left here is called an ESP8266. And this little chip actually has GPIO pins on it, so those input-output pins, and it also has a Wi-Fi circuit on it. And when you combine that with something like the one on the right, that's an air quality sensor and a gas sensor. Now you can start putting together something very quickly and very cheaply that will push data to the cloud. And I'm going to go off script for a second, and an interesting story. Kaz and I had prepared this talk, and we were rehearsing it last week with the VP of our division. And one of the feedback he gave us was hey, you don't have any small, simple sensors on there. You're doing lots of cloud stuff, and you're doing lots of mobile stuff, but you don't have any IoT sensors. So you should really build one and put it in there. And this was last Wednesday. And the environment that we live in now is so cool that we were able to, thanks to Arduino and thanks to the Maker community, to be able to build the demo that I'm going to show shortly, in just a couple of days. And the longest part of that, can anybody guess what the longest time in building the demo was? No, it wasn't actually testing. It was waiting for the parts to be shipped from Amazon. I'm an Amazon Prime subscriber, and it took 2 days, but it only took 3 days to build the whole thing. So, it's an amazing time to be alive, I think. The amount of things that you can do, the amount of creativity, and the kind of things that you can build, it's just, I find it so cool, and I'm really happy to be alive right now. So let's take a look at an example of how you'd use one of these. Consider a building like this one. And say in a building like this, we could put sensors like this for air quality around the building. And when they're around the building, then we can start tracking the air quality in that building. But that's just an instant status. We can tell the stuff here on the south side of the building, the air quality isn't great. And then on the north side of the building, the air quality is very nice. But what would usually happen if you work in an office like this? People on the south side are going to go and adjust the thermometer, adjust the thermostat, the fans will kick in, and then people on the north side are going to be too cold. It's wouldn't it be great if we could intelligently adapt the building? Or what if there was a disaster and there was like maybe a carbon monoxide leak, and our sensors are going to show that carbon monoxide leak, and I don't know how well you can see it here, but the leak is primarily centered around the exit, and if people are being driven towards the exit, they might be driven towards danger. But when we've got cheap sensors like this, we could say, hey, look, instantly we can have an alternative exit. But what if we can go even further? What if we can go even further and then think about scenarios where machine learning comes involved and we can start predicting things? Like maybe we can predict the best times of the day to keep the fans on to maximize air quality and reduce our energy footprint. It's good for the environment. Or maybe we could, if there was a gas leak or something like that, we could predict the path of the gas leak based on testing and based on machine learned models, so emergency responders would know where it's safe to go and where it's dangerous to go. And you know, we all love our emergency responders and we want to make sure that they're safe. Or maybe we could look at what the impact by modeling what would be of like rearranging our office. What if we have more people sitting in the north and less in the south? Or what happens if we host a big event? And you know, this building is actually one of the offices in Google Seattle. And up on that top left-hand side there, that room called Center of the Universe is actually where we host a lot of events. And it'd be good for us to understand the air quality when we do so. So if you've got a lot of devices like this, there's a product called Cloud IoT Core. And the idea behind Cloud IoT Core is it's fully managed and allows you to easily secure, connect, manage, and ingest data from all of your devices. And then once you have that, then you can start doing interesting things like pulling the data out using BigQuery, using Cloud ML, using Cloud Data Lab, using Cloud Studio to be able to then build models and then run inference on these models and have analytics behind that. But let me give a little demo of environmental monitoring and what it would look like. So if we can switch to the Wolf Vision. So this is the device I was talking about. So this is a simple Arduino device. I'm not using the Wi-Fi. In this case, I'm just using a wired one. So I have a shield on top of the Arduino with a wired internet, just so we can make sure that the demo would work here. And then this little device is the air quality sensor. And so it's like, right now it's measuring the air quality in the room. And so that's measuring for particulates, it's measuring for gases, carbon dioxide, carbon monoxide, natural gas, all that kind of thing. So we kind of want to trigger it by kind of polluting the air a little bit. Any ideas how we could do that? I'll just breathe on it, because we all breathe out carbon dioxide, right? So I'm going to breathe on it. I've always wanted to do that in a session. And now if we switch to my laptop. So on my laptop, we can now see I have a Firebase running here, and I'm using Firebase Cloud Firestore. And on Cloud Firestore, I'm actually detecting and I'm getting the readings from this little device. So we can see the readings up here once they come up. Look here at the reading, like 57. That was a moment ago when I breathed on it. 54. I've actually gotten it up to 70. I must have eaten something bad. The usual background here is about 42. So what's going on here? How has this been done? Well, with Arduino, it's super simple to write code in C. And can we switch back to the slides? It'll be a little easier to see the code. So if I go back to the slides, we can see this is the kind of code that you would have written in C on an Arduino. And all I'm doing is I'm reading pin 0. This is plugged into data pin 0 on there. I'm reading that, and then every 2 seconds I'm reading it again. And then what I'm doing with that is I'm posting that to a URL, and then that URL is writing it to Firebase for me. And that's all you have to do. It's really that simple to build a sensor to start monitoring air quality. Very, very cheap, very, very simple. And then when you aggregate the data from all of these sensors together, if you've got thousands of them in the cloud, then you can start building some really intelligent solutions. But there's something to take into account when you're doing IoT, and that's think in terms of security. So data security is very, very important. Obviously, these things are just generating data and pushing it up to my database, but a smart hacker might be able to figure out how I'm doing that and then get access to my database. So you've got to think in terms of data security. And a pattern that I usually like to follow for this, and for good reason too, is instead of pushing from the devices directly up to your databases, have something within your firewall that they are pushing to, and let that act as a proxy, and then that proxy will proxy out to your databases for you. So then you'll have a secure connection between that proxy and the databases, and then hopefully that secure connection will be enough. And the reason for that is also to do it as an internal thing, was that the power limitations on these things mean that a lot of these will only support HTTP. They won't support HTTPS. So that's why in my code a moment ago, if you looked closely, you would have seen that I was just calling, I was just making a client.connect server, 80. in that case, because it's just an open HTTP connection. So that was to my internal proxy, and then the internal proxy was sending it out to the cloud. So things to consider, very cheap, very easy for you to build systems like this one. Coding with something like Arduino in C is super simple. There's tons of APIs and tons of examples there that you can just adapt, and that's what I did in this case. I'd never touched an Arduino before last Friday, and it took and I'm not particularly smart, and it took just a couple of hours to figure out how to hack some of the code that they had provided to be able to build this and write my data up to Firebase. So that's on a small, simple sensor, but now let's take a look at what happens when you go cloud scale.
Okay, thank you.
Thanks, Kaz.
So that was a very simple scenario. And let's take a look at another scenario where we would have a little bit smarter devices, such as camera. If you take a picture with a camera, you may want to detect some object, what kind of object you would have in the images. And TensorFlow provides an API to do that. That is Object Detection API. So by using the Object Detection API, you could have the labels of each object in an image, or you could have the boundary boxes, and you could have the scores. And it's really simple to use the API. For example, you can just download the model file for the Object Detection API, and you can have the dictionary for the tensors with the model file of the model. Then you can pass your images to the dictionary, and that's it. So you would get the output dictionary that would have the detection results, such as the number of the objects you would have, or classes of objects, or the boundary boxes, and the scores. It's so simple. So, for example, you could have the Raspberry Pi with the camera attached to a shopping cart so that you can take a picture of the inside of the shopping cart and apply the Object Detection API to detect what kind of items you are having, or how many of them you have in the cart. And we can use the Cloud IoT Core combined with the Cloud Machine Learning Engine to build a system that provides the production level scalability and availability. For example, if you want to build a smart camera system for the shopping cart, you can have a Raspberry Pi and a camera attached to the shopping cart, then use the Cloud IoT Core to collect all the data, stored data, or storing data on the Cloud PubSub, which could be the backend for your server. And we could use the Google Kubernetes engine, or GKE, as an orchestrator for orchestrating everything happening at the cloud side. And finally, the GKE would be sending the data to the ML engine. That's where we are running the prediction with the Object Detection API. Let's take a look at the demonstration. So I'd like to use the webcam to show how
Switch to the laptop, please.
Yeah. So this is how it looks like. So it's a very small card, miniature card. And we have a Raspberry Pi and display and a camera. So if you put something like, this is a fake eggplant. I bought it in a Japanese store.
Also known as an aubergine for us Europeans.
Or a tomato.
Also known as a tomato.
How Object Detection API would look like. So please switch to the, I should ask him, yeah. So let's wait a while.
I need to refresh. Should I refresh?
Is it working? Maybe the network issue.
What network?
Oh, yeah.
There we go.
Here you go. So, thank you. So it's so easy to detect what kind of the object and how many of them you have in the shopping cart. So please go back to the slide. So that worked. So that was a very simple scenario where we just counted the items and classified them. But you may think that what's the point of using cloud for this kind of detection? And actually, that is true. You can run the Object Detection API just inside the TensorFlow, just inside the Raspberry Pi box. And you don't have to use the cloud. But if you can collect all the data at the cloud side with the thousands of the records, then you can extract some collective intelligence from thousands of the past records. For example, you can train a machine learning model with the order of the shopping items you are adding to the cart, thousands of them. So you can train a machine learning model that can predict what will be the next item you will be putting into the shopping cart. That will be reflecting the location proximity, starting from the vegetables and fruit and meat, like a chicken and spices and pasta, based on the already past history of the shoppers. And you can also have a small display with it, showing the recipe recommendation with the next item to add. That could be working as a navigator for the shoppers. So let's call it as a smart shopping navigator. And what kind of machine learning model we should design for implementing the navigator? At first, we have to represent what kind of items you have in the cart. So if you have the tomato in the cart, we may have the one hot vector that represents the tomato in your cart. In this case, you would have a 1.0 as a value in the vector. And if you put eggplant in the cart, you would have another 1.0 value in the vector. If you have the chicken, then you would have another 1.0 for chicken. So these multiple one-hot vectors represents the cart item history. And with TensorFlow, you can write code like this. So you would have a dictionary for shopping items, and you can call the one-hot function to encode the shopping items as a vector. And then you can have the multiple vectors that represents the cart item history. And now we have the history, and how do you detect the changes in the history? In this case, you can use the convolution, single-dimensional convolution, or 1D convolution. And convolution in machine learning is usually used to detect the certain patterns in a local group of the big data. For example, if you have a 2D images, you can apply a 2D convolution to find some shapes or patterns in the images. That is how CNN, or convolutional neural network, works for image recognition. But you can also apply the convolution to the single-dimensional data, such as time series data. For example, you can apply the 1D convolution on the cart item history. They can detect that what kind of changes that happen inside the cart items. And then you can flatten the output to get the result. And with TensorFlow, you can write the code like this. You can call the conv1D function to apply the single-dimensional convolution, and then call the flatten to get the result. So now we have the cart item change history, and we may also want to take in other factors, such as seasonality, whether it's a winter or summer or time of day, because shoppers may want to choose different food items based on the seasonality, whether it's a summer, hot day, or whether it's a cold day. So we put everything into a single MLP, multi-layer perceptron, which is a classic old neural network with the 3 layers, to predict the next items to add. With TensorFlow, you can write code to concatenate everything into one tensor, and you would define the 3 layers of the MLP, and that's it. Let's take a look at how the Smart Shopping Navigator works. So,
switch to laptop, please.
Yeah, please switch to the laptop. If you put the eggplant, then it should detect the eggplant.
I see a shadow.
Yeah. So you are watching the same screen I'm watching here. So at the right side, you see the what kind of the recipes and items are recommended. So it looks like the system recommends the pasta, eggplant, baked. And I want to make a pasta, so I would put the tomato. Then the navigator would show the other things you have to add would be, I already have it, but eggplant, tomato, and I want to make the, yeah, maybe I have to use the, I want to make a pasta.
The mouse is also working.
Mouse is working. Or somehow it doesn't show pasta, but anyway.
Refresh.
Yeah, I can try putting just chicken. So that you can just follow the items on the screen so that you can find all the items to make the eggplant tomato pasta. That's how it works. Okay, thank you. So please go back to the screen, the slide. So as you have seen on the demonstration, by showing the recipe ideas and next item to add, it works just like a car navigator for the shoppers. So the shoppers can just follow the next item to add to fill the cart with all the items required to cook with a certain recipe. And that was the example of how the cloud can be empowering tool for the IoT devices, not only for collecting data, but also you can analyze it and learn some collective intelligence from it. It's not just an IoT anymore. It's an Internet of Smart Things. And this demonstration was actually built by a Google Cloud partner called GrooveNodes. And they have open sourced everything on the GitHub. So if you are interested, please go to the GitHub and search with Smart Shopping Navigator to find out what kind of code you would write. And this is also, they also provide a production solution called Magellan Blocks, where you can have the user interface to build the whole data pipeline for collecting the IoT data and analyzing it and learning, training the model. So with that, I'd like to back the stage to Laurence.
All right. Thank you, Kaz. Pretty cool stuff, right? So now the third scenario that we wanted to look at was like on-device inference and training. And like there's a few different types of devices you can do inference and training on. So for example, you can do it on a mobile phone or a tablet. You can do it on a Raspberry Pi, or you can do it on an Android Things device. And there's a really cool video of doing it on a mobile phone or tablet that I've put at this QR code. So take a look at this QR code, watch this video. I'm not going to show it here, but the idea behind this video is that if you went to the TensorFlow Summit, you would have seen it, but it's farmers in Tanzania, in Africa, who don't have cloud connectivity and who rely on a plant called cassava, that if the cassava plant gets diseased, it can kill and impact an entire crop, and it's hard for humans to eyeball it and see it, but they built a machine-learned system that all you do is they wave their phone over the leaves, and they can diagnose diseases early. It's really, really cool. So that kind of on-device inference without any cloud connectivity is possible through something called TensorFlow Lite. With TensorFlow Lite, you can also do inference and training on a Raspberry Pi. And I have a car here that I'm going to show in a moment that's driven off of a Raspberry Pi. And if you were in the sandbox area, you would have seen cars like this one self-driving around. But basically, there's a little camera at the front here. And what I would do is I would manually drive the car, record what I'm doing, and then based on the telemetry that I'm sending to the car to drive it around and the corresponding video, that's giving us the features and labels that we want that the car will then remember and then use that to self-drive. If we switch back to slides for a moment. And then finally, there's the third one, which we'll show in a moment, is on an Android Things device. All this is made possible because of TensorFlow Lite. And I strongly recommend check out TensorFlow Lite and check out the talks on TensorFlow Lite. But the idea behind TensorFlow Lite is that if you want to train a machine-learned model, we have a bunch of converters that will then flatten that model and shrink it to make it more mobile-friendly. There's an interpreter core then, which is used to execute that model, so you can do inference on the model. So for example, things like if you want to do an image classification, it'll do that locally on the device without round-tripping to the cloud. And then there's all the stuff that's needed, like operation kernels and hardware acceleration, to take advantage of the mobile hardware that you have. It runs on Raspberry Pi, it runs on iOS, and of course it runs on Android, and it works really great on a Pixel. I have a Pixel 2 up here, and if you want to see a demo of it, come see me afterwards, and I can show like real-time inference on the Pixel. It doesn't really work on the stage that well. Now here's a video that I shot of me doing real-time inference, and you can see like it saw the coffee mug correctly, and here, you know, this coffee mug kind of looks a little bit like a mixing bowl, so it got like, at some points it felt like a mixing bowl, and yeah, I know that's a horrible product placement for my show, Coffee with a Googler, but I had to do it. And here it was able to recognize a mouse and stuff like that. So this is what it would look like running on Android. And so for the self-driving car that I've been talking about, so you can see on the right is the Raspberry Pi, and on the left is something called a pulse wave modulation controller. And that's what actually drives the car itself. So I have TensorFlow Lite running on the Raspberry Pi, and that's what will actually drive the car. And this is built on a project called Donkey Car. And if you want to go and take a look at Donkey Car and details about Donkey Car, they're at this URL. So should we take a look at what it would look like to actually train the car? So if we can switch to my laptop, please. And so I've actually started up the Raspberry Pi on the car, and there's a little web server running on that. So let me go and see if I can access it. Hopefully it'll obey. Oh no, it's refusing to connect. Hang on. Oh, sorry. CDD2. So what I'm doing is it runs on Python, so I'm just running the Python code. Sorry, Kaz, to make you hold it so long. So this is actually booting up the web server that's on the car that I would then use to train and drive it. So it'll take a moment just to boot that up. But what will happen is, like, so if I want to control the car when I'm training it, obviously it's hard for me to do it on it, so it has that little web server. The web server, it's connected to a hotspot on my Pixel, and my laptop's connected to the same one. So it's starting up that server. It looks like that server's done. Yep, and here it is. So as Kaz moves it around, you'll see that one. And if I were to like try and drive the car, I made a bit of a mistake. If you've been over to the sandbox, you would have seen the cars they're using are really small ones. And I didn't read the specs properly, and I bought this one, and it's an absolute beast. It goes really, really fast. I don't dare put it on the floor and start driving, because it will take off, and it will land about 3 rows back. So watch out, Kaz. And you see, it's like, this is what it looks like if I'm driving and training it. I can steer, and I can control it like this. So it's, what it's doing right now, it's recording what it would see on the webcam from the car actually moving, and storing all that stuff that would then use to train a TensorFlow model for that specific area. So when you see the cars over in the sandbox, they're on that figure of an 8 track. So we drove them around that figure of 8. We trained them in that way. And then instead of launching it in training mode, as I have it now, you just launch it in drive mode, and they go and they drive themselves. So you can build one of these as a donkey car. It's OK, we can put it down. We can build one of these using the donkey car project. It costs, this one is a little bit more expensive, but they generally cost maybe about $200 total for everything. And you can build your own little self-driving car, and it's all open source. It's really, really cool. So thank you. Can we go back to the slides, please? The motor on the car is really loud, so I'm going to turn it off because we hear it whizzing. OK, so that's what it's like to train a donkey car, and that's the kind of, with on-device inference, you can then have a, believe it or not, a model self-driving car. I think that's really cool. Now, the next thing was Android Things that I mentioned, and did everybody get one of these? Right? So these are just so cool. So this is like just a little, this one isn't actually a Raspberry Pi. It's a different developer board, but a similar concept. And with Android Things being able to execute stuff, and with TensorFlow Lite running on Android Things, you can start doing inference. And has anybody done the Code Lab? Have you tried it out to do inference on these? Try it out and build it, and you'll be able to do things like this. So this afternoon, back in my hotel, on this device, I kind of pointed it at a water bottle, and I thought it was interesting that it gives you 3 things that it thinks it is. It thought it was a water bottle, a pop bottle, or toilet tissue. I don't know if it's because of the circular parts of it or anything like that. And then I tried it on this one, and it said a coffee cup, a coffee mug, a cup, or a measuring cup. And particularly the way the handle is placed, I thought it would be really interesting to try and fool it. With the handle, the way it's placed, and I thought it might think it was a pitcher, because sometimes when I do mugs like that, it kind of classifies it as a pitcher. And then, of course, this one, I tried on my Android, my little French Android, and I thought he was a piggy bank, a teapot. I guess he's a little teapot, the way he's standing. Or maybe even a spotlight, and maybe it's the shape of it or something like that. But that's the stuff that's built in, and like when you assemble this device that you've got, that app is actually already running on here, and that app is open source. And one of the really cool things you can do is that the image model that app is trained for, you can actually retrain that for your own images. I've been working on a version of it that I'm going to add to the car, and maybe we'll be able to talk about it at a future I/O, where I'm retraining the car to recognize things like traffic lights. So if it sees a red light, it will stop. If it sees a green light, it will go. And all the code for you to do that is available with this kit when you get it. So give it a try. And for those of you watching online, just check out Android Things. You can buy these kits. They're relatively cheap, and they're so much fun to play with. So the Code Lab that I mentioned, if you're here at I/O, you can go over and try it out. If you want to try it on your machines at home, the URL for it is at this QR code. Go give it have a play with it. It's a lot of fun. So in recap, we spoke a little bit about Internet of Things and AI, and about the trends that are happening, that the explosive growth that is going on, the growth of actual devices, and the amount of data that they're producing, and then the things that you can do with that. We looked at, like with the sensor data on an Arduino, we looked at cloud scale AI, and we looked at on-device inference. Now, there's a whole bunch of things that you can do to go and take a look at. OK, come on, slide, animate, there we go. So things that you can try out, number 1, writing data from your Internet of Things device to cloud storage. There's great details on it at this URL. If you want to explore the TensorFlow Object Detection API, which is what Kaz was using here when it was detecting tomatoes and eggplants or aubergines and that kind of stuff, you can find details on that at this link. IoT and the Cloud ML Engine, details for that are at this link, and this one. And TensorFlow and TensorFlow Lite, and all of the mobile scenarios that I was showing here were based on TensorFlow Lite. You can learn about that at this link, or attend the talks if you're here. And then finally, exploring Android Things itself. I find it super cool. And it's really nice because if you're already an Android developer, you can start building stuff using your existing skill sets. When I was doing the thing for the Arduino here, I had to give myself a crash course in C, but if you, like I said, if you're already an Android developer, whoops, and you're used to using Java or Kotlin to build your Android apps, then you can start building Things apps with that too. So with all of that, we just want to say thank you very much. Feedback is always welcome. We'd love to hear it, and it's at this URL. Thank you.